Here we are asked to calculate the total area, and let's say we have a lawn that has the length of 11 meters and width of 5 meters, and we have a patio that has 2-meter width and 11-meter length. So there are two ways you could go about calculating the area. One is you could say, well, area is length times width, and here my length is 11 and my width is 5 and a 2, so 5 plus 2. Or you could say, well, I could also add the area of the lawn plus the area of the patio. So we could say area 1 plus area 2, and that equals, for the lawn, it's 11 times 5, and for the patio, it's 11 times 2. So let's see if with both methods we get the same result. 11 times 5 plus 2 is 7. So 11 times 7 is 77. And with the second method, 11 times 5 is 55, plus 11 times 2 is 22, and that also equals 77. And we are talking about area, so it's meters square in both cases. So what this leads us to is what's called distributive property. So 11 times 5 plus 2 equals 11 times 5. So we multiply 11 by 5 plus 11 times 2. So 11 times 2. And it's called distributive property. Before we go on to examples with variable terms, let's look at some examples where we just have numbers. For example, where you have 7 times 17, you could rewrite it according to a distributive property. You could say 7 times, and now 17, and I can rewrite as 10 plus 7. This makes it easier for me to see the result now, because 7 times 10 is 70, and 7 times 7 is 49. So I have 119. Many of you already have used this method when you have to multiply bigger numbers and calculator is not handy. Let's try another example. 9 times 13. Again, you could split 13 into 10 plus 3. And now 10 times 9 is 90. And 3 times 9 is 27, so that equals 117. What if you had bigger numbers? Let's say you had 113 times 7. Again, you could split it. You could say, well, I'm going to multiply 7 by 100 plus 10 plus 3. Here I have 100 plus 10 plus 3 is 113. So really all I did is rewrote 113 as a sum of 3 numbers. So now I can multiply 7 times 100 is 700, 7 times 10 is 70, and 7 times 3 is 27. When I add it all together, I get 797. Here we have to simplify the expression. Normally we would look at the operation in the bracket to perform. Here they are not like terms, so we can't add x and a 3. What we could do is expand by using distributive property. So we can multiply 4 times x plus 4 times 3. And that equals 4 times x we can write as 4x plus 4 times 3 is 12. Question B, similar situation, we'll use distributive property. 5 times x plus 5 times y equals 5x plus 5y. Question C, we have 3 times 2a plus 3 times 5 equals 3 times 2a is 6a plus 3 times 5 is 15. Question D, we have negative 3 times 6 plus negative 3 times 4a. And that equals negative 3 times 6 is negative 18 plus negative 3 times 4a is negative 12a. We could leave an answer like that, or we can simplify it further by saying 18 plus and minus we can rewrite as take away 12a. Question E, we can use the distributive property. 3 times 6y squared plus 3 times negative 4z equals 3 times 6y squared is 18y squared, and positive 3 times negative 4z is negative 12z. So 3 times 6y squared, 18y squared. 3 times minus 4z equals negative 12z. Here we have negative 3 times 2x plus negative 3 times 4y, and that equals negative 6x plus negative 12y, and that equals negative 6x plus a negative number we can rewrite as subtract a positive number. Question G. Negative 5 times the first term in the bracket, 2y to the power of 3, plus negative 5 times the second term in the bracket, negative 3xyz, equals negative 5 times 2y to the power of 3 is negative 10y to the power of 3. Negative 5 times negative 3xyz equals positive 15xyz. And we can rewrite it without brackets because adding a positive number we can rewrite as just adding 15xyz plus 15xyz. Question H. Here there's no number in front of the bracket, just a negative sign. What that really tells you is that there's a negative 1, because remember, any number times a 1 is just number itself. That's why we can't see that 1 there. So negative 1 times 2x squared plus 5x minus 10. You don't have to rewrite it like this. I'm rewriting it to demonstrate that there is a 1 there and help us see that. So now we have negative 1 times 2x squared plus negative 1 times 5x plus negative 1 times negative 10. And that equals negative 1 times 2x squared is negative 2x squared. Negative 1 times 5x, negative 5x. Negative 1 times negative 10 plus 10. And that's the final answer. We can't simplify any further because there's no like terms in this expression. Question I. Remember again that if there's negative in front of the bracket, that simply means that there's negative 1 in front. So it's negative 1 times the first term in the bracket, which is y, plus negative 1 times the second term in the bracket, which is negative 4z, equals negative 1 times y is negative y, and negative 1 times negative 4z is positive 4z, equals negative y plus 4z. Question J. Negative 1 times negative 2x plus negative 1 times positive y equals negative 1 times negative 2x is 2x plus negative 1 times y is negative y, and that equals 2x minus y. Question K. Minus 3a squared times the first term in the bracket, 2a, plus minus 3a squared times the second term in the bracket, 5, equals negative 3 times 2, negative 6, a squared times a to the power of 3, plus negative 3 times 5, negative 15, and we have the variable a squared there. That equals negative 6a to the power of 3, take away 15a to the power of 2. Question L, 3a to the power of 3b squared times 6a plus 3a to the power of 3b squared times the second term in the bracket, 4b, equals 3 times 6, 18, a to the power of 3 times a to the power of 4, and we have b squared there, plus 3 times 4 is 12, a to the power of 3, and b squared times b is b to the power of 3.